Right, recording is restarted. Right, let's look at pendulum waves. And so I just got a few demos that are related to some kind of waves or periodic motion. You guys see 15 individual pendulums? Right, you guys see kind of a sort of a curve to it? Maybe possibly like a square root shape, maybe? They're almost lined up in a straight line, but see, maybe a slight curve to it. But 15 individual pendulums. Wow. When you guys see the DMA, right about there is the halfway point, and everything after the halfway point is like the first half in reverse. Yeah, you overlay them. And back to the beginning. Yeah, and then it just cycles over again. Yeah. Let's check out some Chladni plates. We got this guy talking about. Here we go.
You can't see it, it is vibrating too fast. So I'm going to sprinkle it with a little sugar. Sugar, in order to sweeten the sound. Sugar. Sprinkle it with a little sugar. And now I'm going to bow it and watch what happens. I say that's very pretty. I say that's very pretty. Now let me bow it in another place. Stay right there. Stay right there. I bowed it in another place. The sugar is a little sticky, I'm afraid, because it is damp and it has taken up some water. Let me bow it again. That's what I had first. Let me bow it another way. I'm having a little trouble with that plate. I don't know why. Let me take another one. Another one. Different size, perhaps. Different material, perhaps. Let me bow this. Oh, I say that's very pretty. Let me bow another rectangular plate. These, by the way, are called Chladni plates. Capital C-H-L-A-D-N-I. Chladni showed these to Napoleon. And what did Napoleon say? Professor Chladni makes musical sounds visible. Now, who would believe that there could be seen anything pretty on this plate? But I'm going to sprinkle it with some sand. And I'm going to bow it in the middle. And this is what I got before. So what the plate does, how it vibrates, is governed by its size, shape, nature of stuff, how it's fixed, and how I bow it. Because I'm going to bow this in a different way. Watch. And I say that's very pretty. Now, what will a circular plate do? Aluminum, centrally fixed. Oh, let me bow it without anything on it. Notice in the first bowing, I overbowed, excited and harmonic. So I'm going to sprinkle it with sugar, sand, and bow it. And I say that's very pretty. And you notice I have a six-starred figure. Here is a smaller plate, aluminum, fixed again centrally, the same thickness as the other, but because it's smaller, it should have a higher pitch, less inertia. Very pretty. Now let me bow this one with some stuff on it. Oh, that's 6 again. Let me try to get 4. Oh, I'm getting 8. I'm getting 8. 3, 5, yes, I'm getting 8. Let me try to get 4. You notice what's happening. 4, 6, 8, 12, und so weiter, and so further. Not so well defined. Well defined for 6. I'm going back to this other one to see if I can't get 4. Yeah. There. 4. So we have the wonderful investigation of Chladni plates and Chladni figures. Let me go back. Vibrating bars and plates. Point of view. Here is a goblet, a glass. Is that a vibrating plate? Sure. It's a plate that has been folded up and it has some acoustic properties. Now, what have I done? I filled it to a certain depth of water. There is a certain measure of glass that's free of the damping effect of the water. And you know what we do. We stroke it, and listen. Listen. The same kind of glass, differently loaded. Another kind of glass, different depth of water, different resonating air chamber, different wall thickness, all together.
Ben Franklin actually invented a musical instrument that was based on that property too. It's called the glass harmonica. Yeah. One more demo for you guys. This is called a Blackburn pendulum. Guess it's like a pendulum within a pendulum. Okay, we've got all kind of crazy shape. I wonder what kind of crazy shapes those make. Who could I ask about that? How about this guy?
Some lead weights around this funnel to make it heavier, to give it larger inertia. Now I'm going to draw this off in some arbitrary way and let it go. Now watch what happens. I say that's beautiful. Now its motion is damping out. That is getting less and less in amplitude. And notice the pretty figure that results. Now let me fill it again. And let me change this position. Oh, I may have a little trouble here. I need several hands. Let me change the position. There, I've gone way up there. Well, no, with only 2 hands, I can do just so much. So let it slip out. No hurt. Okay, now I'm going to start it again in another position. Watch it. We should, I suppose, get rid of this figure in order to see subsequent ones, but you'll get the idea. Well, I'm having a little trouble. Shame, really, to miss. This one needs to be viewed more properly that way. Or one such. Look at that. Or look at this one. Incredible designs. Or such. Incredible. Oh, let me turn that so the camera gets a better view of it.
You guys have a good afternoon.